In this video, we're going to be taking a look at the composition of resistors and how the resistance is varied within each of these different resistors, and then also how to use a color code chart as well. So you may have seen resistors that look like this, which have two conductive ends and are wrapped in an insulated material and then have some colored stripes on them. Now what they do is on the inside, there's typically a ceramic core that is wrapped in carbon. So carbon is the part that you see that's sort of dark gray. And what they do is fairly simple. They make helical cuts in the carbon to vary the path that the electrons take. And then that way they change the resistance. And here are the two ways that they change up the resistance. Now what they can do is create slits where they have narrower paths, which creates less physical room for the electrons to pass through. So in that case, there's going to be less electrons and charges passing through, causing more resistance and less current. And then also, if we create a longer winding path around that resistor, then it's going to create a longer, more resistive path. So basically, once you try to step up the resistance, you're going to do one or a combination of those things to increase the resistance. Now let's go ahead and take a look at this color code chart. So basically what you're going to do is your final band is going to be your tolerance, and then everything before that is either going to be a specific numerical value or a multiplier. So a 4-band resistor is fairly common. So let's go ahead and take a look at one of those. And it's got 3 bands that are going to consist of either a number or a multiplier. And the very last one is always going to be the tolerance. So how it works is out of the initial 3 bands, the last one is always the multiplier. So the first band is green, which correlates to the number 5. The second band is blue, which correlates to the number 6. And then the yellow band is the last one of that initial set, which is going to be our multiplier. And then the yellow band says 10K. So multiplying this by 10 would make it 560. And then that would be kiloohms. Now the very last band, this one over here, is going to be our gold band. So the gold band is our tolerance, which says plus or minus 5%. And they're basically saying that there is a bit of a percent error for each of these resistors. So obviously the smaller the tolerance, the better. Then it's going to be more spot on to the initial resistance value that you calculated in the beginning. So all you have to do is find 5% of 560. So basically just taking 560, multiplying it by 0.05. And then from there, you get 28 kiloohms. So basically on the lower end of its tolerance, you would have 532 kiloohms once you subtract that 28. And then on the lower end, you would have 588 kiloohms once you add that 28 kiloohms to the 560. And then that would be the range that it falls into. Now, when you're taking a look at the 5-band code, it's a very similar process. You're going to take the first set of numbers, or the first set of colors, excuse me, and then the very last one is going to be the multiplier again, and the very last one is always going to be the tolerance. So the last one we're going to leave alone till the very end, and then just take a look at our first few. So if I have a 5-band code, I know that my first 3 are going to be my single digits. My last one is going to be my multiplier, and then, like I said, we're going to take care of the tolerance at the end. So first band is red, which correlates to the 2. Second band is orange, which correlates to the 3. Third one is purple or violet, which correlates to the 7. And then the black is the multiplier times 1, so it just stays 237 ohms. And then my last band for the tolerance is brown, and brown is plus or minus 1%, which is pretty good. So plus or minus 1%. So just as we did before, you can take 237 times 0.01, and that would give you 2.37. So we're going to subtract 2.37 and add 2.37. And that would give us our full range with that tolerance or that percent error included. So to sum things up, anytime you look at a certain code, 4-band or 5-band in this case, you're going to sort of ignore the last band temporarily because that's just going to be your tolerance at the end, and then focus on the first 3 or 4 bands of that first set. That last one is always going to be a multiplier. So for the 4-band code, it's always going to be 3 in your initial set, and then the last of those 3 is going to be your multiplier. And then for the 5-band, you're going to have an initial 4-band set with the 4th one being your multiplier and the 5th one being your tolerance. Once you want to calculate that tolerance, all you have to do is multiply it by that particular percentage, see how much of that 5% or 1% is in our case, which this top one was 28, and then add and subtract that number to the initial resistor value, and then you can get your range of resistance for that particular resistor. So I hope that was helpful to you and doing some color coding and understanding the composition of a resistor. Thanks.